Hello, my lovely followers. Let's solve physics together. So now, this question is coming from a very simple topic, which is work, energy, and power. So, for you to understand what is happening on this particular question, first and foremost, you need to understand what we call law of conserving what? Energy. Remember, law of conserving energy states that energy can neither be what? Created nor what? Destroyed, but can be converted from one form to another. This is what is going to make you understand this particular question. Therefore, from here now, let's proceed and check what we've been given. So, due to the size of the board, the statement of the question is not included, but I'm going to make you understand what is happening on this particular question. Remember that the stone took 2 seconds for it to fall from this point up to this point. So the time which is given here is what we call 2 seconds. Therefore, acceleration is due to gravity, which is 10 meters per second what? Squared. Remember that the stone has a mass of what? 2 kg. So we are talking about a stone with a mass of what? 2 kg. So we are saying mass is equal to 2 kg. So now, let's proceed to question A. Question A is saying, name the form of energy possessed by the stone before it falls. Name the form of energy possessed by the stone before it falls. Remember, we have two common forms of energy. Mainly at grade 12, we only focus on kinetic and potential. So now, if they are saying before it falls, meaning that the object is not moving, so the form of energy that it is possessing on top of this cliff or building is what we call potential energy. So, question A, we are saying, question A, solution for question A, we are saying name the form of energy possessed by the stone before it falls. We are saying the form of energy is known as what? Potential what? Potential energy. So before the stone falls, it is possessing what we call potential energy. Let's proceed to question B. Determine the height of the cliff. Determine the height of the cliff. So now, for you to know the height of the cliff, first and foremost, you need to understand to say the acceleration which is given is due to gravity, which is what? 10 meters per what? Per second squared. And time is also given, which is what? 2 seconds. Remember, we are dealing with a stone of mass, 2 kg. Therefore, for you to find the height of the cliff, all you need to do is to check this particular formula. So we are going to say height is equal to what? Ut plus what? Half what? Gt. Because if it is falling, meaning that acceleration is due to what? To gravity. Gt what? Gt squared. Remember, our initial speed is 0 and time taken is what? 2 seconds. And where there is the u, we are going to replace a what? We are going to put a what? A 0. So this simply means that we are going to say 0 times t, of which the formula that we can use for you to find the height, we can erase this one and make it be simple, because I want you guys to understand, more especially the GCE who are writing the exams in June. You need to understand so that you get the exact formula. So with you guys, H is equal to half what? GT squared. So this is the formula that you need to use on this particular what? Question. Now, let's proceed. Determine the height of the cliff. So, with what we've been given, the value of G is 10 meters per what? Per second squared, because it is acceleration due to gravity. So we are saying the value of what? The value of G is 10. So we are saying height is equal to 1/2 times what? 10 times time, which is given is 2 seconds, of which we are going to say 2 to the power 2. Now, you guys, you are mathematicians. Remember, a number raised to the power 2 simply means let that number multiply itself. So we are saying, we are going to say these two will be divided into a 10. We are going to get a what? A 5. Then since we are getting a 4 this side, so we are saying 1 times 5 times what? Times 4. So height of the cliff, 1 times 5 times 4, we are getting 20. 20 what? Meters. This simply means that the height of this cliff is what? 20 meters. So we are saying the height of this cliff is what? 20 meters. Make sure that you pause the video. You write down the questions, then you understand the explanation. Remember, this question is under law of conserving what? Energy. You need to focus and you need to understand. So let's proceed. We are saying the formula you can use for you to find the height, h is equal to 1 over 2 times gravity times what? Time. Where there is g, you are going to replace by what? A 10. Therefore, you compute all these numbers, then you get the value of height to be what? 20 what? Meters. Let's go to question C, Roman numeral 1. So remember, you pause, you write down the answers, you write down the formula. Physics is crucial if you are not understanding the explanation. So let's follow each other. So let's go to question C. Question C, Roman numeral 1. We are saying calculate the kinetic energy of the stone when halfway down. Okay, this is interesting. Remember, we are talking about law of conserving what? Energy. So now let's get back to our diagram and try to explain what is happening. So halfway down the cliff, this simply means that it is half of the what? Of the height, which is the what? 10 what? 10 meters. And going down, we are saying it is also what? 10 meters. But the question is quite interesting. It is asking us to know the kinetic what? Energy of the what? Of the stone halfway down. This simply means that on top of the building, our potential energy is what? On top of the building, our potential energy on top of the building is going to be what? We need to find the potential energy. Remember, PE is equal to what? Mass times what? Gravity times what? Height. If the mass is 2, gravity is 10, height is 20. This simply means that we are going to get the potential energy on top of the cliff to be what? 400 what? Joules. But the question is not asking us to find potential energy. It is asking us to find the kinetic energy, because the object is in what? Is in motion. Therefore, on top of the building, the value of PE, we have a what? A 400 what? Joules. But the value of KE, as it is on top of the building, it is a 0 what? 0 joules. Remember, law of conserving energy. So let's proceed. So as the stone reaches halfway the building, the value of potential energy is half of what is on top. So if on top we have a 400, meaning here we have a what? A 200 joules. But when we consider the kinetic energy, remember, energy can either be what? Created nor what? Destroyed. Therefore, the value of kinetic energy is going to give us a what? A 200 joules. So as the stone reaches halfway of the building, the value of KE, the kinetic energy, is just equal to 1 over 2, which is half times what? 400 what? Joules. So we are going to get half of 400 joules. It is a what? A 200 what? Joules. This is the answer that we are going to find. Remember, law of conserving energy. Quite interesting question. You need to pause the video. You pay attention. Spend much of your time in understanding the question. Make sure that you understand. You inbox me to say, okay, Mr. Soup, I have this challenge. We are going to help you. So let's proceed to Roman numeral what? Roman numeral 2. We are saying calculate the final velocity of the stone as it strikes the what? The ground. Okay, quite interesting. The final velocity of the stone as it strikes the what? The ground. Remember, we are talking about a stone which is what? Falling. So before it strikes the ground, the value of potential energy before the stone strikes the ground, according to law of conserving energy, before the stone strikes the ground, the value of potential energy is equal to what? Is equal to 0 joules. But the value of kinetic energy before the stone strikes the ground becomes what? 400 what? Joules. Remember, energy can either be what? Created nor what? Destroyed. So the 400 joules on potential energy, as the stone strikes or reaches the ground, it changes to what? Kinetic energy, which is what? 400 joules. So let's respond to the question which is asking us to find the final velocity. So let's proceed. This is question C, Roman numeral what? Roman numeral 2. We are going to apply the formula for kinetic what? Energy. So we are saying KE is equal to 1 over 2 mass times what? V to the power what? 2. Remember, we are finding what? Velocity. So we are saying if kinetic energy as the stone reaches the ground is what? 400 joules. Therefore, where there is Ke, I'm going to replace by a 400 what? Joules. I'm going to say 1/2 times. The mass of the stone is what? 2 kg times what? V to the power what? 2. This is quite interesting. You need to understand these things are very simple. So let's proceed. We are saying this is a 2 and this is a 2. We are going to cancel. So we will divide or we are going to cancel. So we are saying this is 400 is equal to 1 times 1 times v squared. We are getting a what? A v squared. Remember, the question is asking us to find final velocity. We are going to introduce the square root, both sides. So we say the square root, a square root and a square, we will definitely going to cancel. Meaning that the velocity of the stone as it strikes the ground will be the square root of what? 400, which is a what? A 20. So we are going to get 20 meters per second squared. This is your tutor, Mr. So make sure you pause the video, you enjoy the lesson. Otherwise, we are going to end here.